My name is Dr. Alan Opon, Senior Research Scientist, and an officer here in charge of the Planting for Food and Jobs program. Our mandate in this government's program, flagship program, is to produce basic seeds, which are normally the breeder and foundation seeds, and then which we will distribute to certified seed growers, and then they will in turn multiply it and then make it available to the ordinary farmer. So by way of quantities, we were involved in the production of maize, rice, soybean, pepper, cassava, and then sweet potato. Maize alone, we were able to produce, we've been able to supply more than 10 tons of breeder and foundation seeds. If you multiply it into the farmer's level, it will trickle down to about 64,000 tons. For rice, we also produce more than 10 tons of basic seed. And then if you multiply it into the farmer's field, it's also a huge number. The same applies to the peppers and then the soybeans. Not only that, we also build capacity of the certified seed growers. We teach them how to produce good quality certified seeds for farmers. Before any program can succeed and the farmers can make good impact, the farmers who are going to use the seeds that we supply, the end users should have seeds that are of high quality. And so the people who produce them, we bring them here or we go to their fields and then we train them on good agronomic practices that will lead to production of good quality seeds and then which will be made available to farmers. On the other hand, also, we build capacity of ordinary farmers or even local or educated farmers. When they come here or we go to their fields, we teach them good agronomic practices and how to raise their productivity, disease control, pest management, fertilizer application, and all those activities.
Bart Lawrence from Biosu Cooperative. We have benefited a lot from Planting for Food and Job program. Before the emergence of Planting for Food and Job programs, our production was very, very low. We were producing around 50 metric tons of maize. But since the introduction of Planting for Food and Job program and the help from crop research, we were able, during 2017 and 2018 season, produce about 200 metric tons of certified seeds. And economically, it has really helped us. We receive input from the government, the ministry facilitated input for us, and crop research provide us with foundation seeds, and we're able to increase our yield.
FM Apia Francis, Biosu Cooperative. Nyame aye adom ma aban de sa program yi by Planting for Food and Jobs. Na aboye bibre sanse se de na kanani ye adwuma no na ma ye production no low sanse se de binya seeds and fertilizer kwa de ye adwuma na ho asama ye din mai ba sanse program yi by ya introduce ye no aboye bibre ama ye production no akosoro ama se nyame adom crop research for domain boy my nsaka seeds aban so aboy ama this fertilizer no wate so aman ma this fertilizer no so nsaka nti ama ya adwuma no etumpon se ne kane no na adwuma no eda low no se de abasoro ama ye pa ama se nyame ya adom kra ma se hybrid no so omode ya franchi chirem ama se hybrid no so no nyame adom yetimi produce ti land ya obedo obenya be say 2 bars no hybrid no so otunya 4 bars ene echi nti hybrid no ye ti ye hwe ni mi say hybrid no better than OPV no nti say ama ya ni age hybrid no ho a ye pese ye de ho ewura hybrid no emu.
Crops Research Institute of the Council for Scientific and Industrial Research, in partnership with the World Food Programme, is implementing a project called Enhanced Nutrition and Value Chains in Ghana. The project focuses on supporting private sector agro-food processors to produce and make specialized and nutritious food commodities readily available at affordable prices throughout Ghana.
I'm Dr. Manfred B. Ewu, Senior Research Scientist, CSIR Crops Research Institute. Vitamin A is very, very important nutrient. Very important for development of the eye, for good skin, for several metabolic processes in the human as well as in animals. Especially in pregnant women, it helps in the development of the fetus in the womb of the mothers. Vitamin A deficiency has serious effects. For example, there is night blindness mostly occurring in children, and for the pregnant women, they have problems in giving birth. So a long-term solution to this problem is to develop varieties of maize that are high in vitamin A. We are using maize as an example because maize is a staple food and is eaten in various dishes. Think about banku, TZ, apele, kenke, and so on and so forth. So a long-term solution to solve this vitamin A deficiency is to develop varieties that have high levels of vitamin A. And the development of these varieties was done in collaboration with the National Institute of Tropical Agriculture based in Ibadan, Nigeria. So CSIR, Crops Research Institute, the team of scientists collaborated with ITA, and we've come out with several varieties that are high in vitamin A. Some of these varieties are crops Ahwodin, we have crops Zifo, we have crops Ahwofe, we have crops Honampa. These are all varieties that have high levels of vitamin A. Vitamin A is also recommended for the school feeding program that have been embarked by the government. And it is our prayer that the program will embrace the use of vitamin A maize in preparation of food dishes for the children, so that they will be able to improve upon their health status. It's very important also in the One District One Factory program, which has been embarked by the government, because most of these maize products can be processed into various products like maize grits, maize flour. We have several products that can come out of the maize.
Since the outbreak of the fall armyworm in 2017, CSIR-CRI has taken a keen interest in finding appropriate ways of eradicating the menace by leading and participating in a number of research interventions. One of such interventions is the pull-push strategy.
I am Stephen Yabua. I'm a research scientist at Crop Research Institute, an agronomist by profession. With this technology, we have three components. We have our maize crop. In between the maize crop, we have our desmodium plant, and outside the field, we have an elephant grass or napier grass. What happens, the science behind all this technology is that the desmodium will push the insect pest, the armyworm, and then the elephant grass at the border will attract the armyworm. So once the desmodium push the armyworm from the field, the elephant grass attracts the armyworm, and then the insect pest sit on the elephant grass and therefore free the maize from infestation. So as you can see, if you look at the leaves of this maize, we didn't spray against any fall armyworm infestation insecticide. No insecticide was used on this field, but the leaves are very clean. There was no infestation in terms of destruction or any other damage down to the leaf. What we are trying to do is that with this fall armyworm infestation in Ghana, if we are not able to manage it, then it's going to affect food security situations in the country, because maize is a food security crop in Ghana. And then without any intervention, especially non-pesticide approach, of fighting fall armyworm, which will have environmental benefit, then we are going to be in a very serious situation in future. So all what we are trying to do is to exploit this non-pesticide approach to manage fall armyworm infestation for increased maize production and for enhanced food security in the country.
I'm Patricia Otindako. I'm a soil and water engineer and part of the push-pull research ongoing at the CSIR Crops Research Institute. The push-pull technology has several benefits. Among them is the fact that the intercrop, which is the desmodium and the napier grass, are also livestock food. But what the soil and water engineering team is currently looking at in this system is the water conservation model that this system applies. Currently, we have an intercropping system where the desmodium is used or intercrop between the maize. The desmodium is also a cover crop covering the soil surface, thereby reducing evaporation from the soil surface. So in effect, we are reducing the evaporation and conserving moisture in this system for the maize plant to use during seasonal droughts or in-season droughts. One major advantage that can be identified with this system is its sustainability. The legume that we plant, the desmodium, is a drought-tolerant crop. The farmer doesn't need to plant it every year. So is the napier grass. So once you establish the napier grass and the desmodium, what the farmer does is to come in every season to plant the maize. And this is a very sustainable way of improving our soil fertility, managing fall armyworm, and also conserving soil moisture for effective plant growth.
The fodder can be used as raw material for animal feed production in the government's Rearing for Food and Jobs program.